Welcome, Sleuths. Today we are diving into the hidden world behind averages, exploring how variability reveals the truth behind the numbers. Central tendency tells us where data clusters, but variability, that's where the real story lives. Let's compare two car battery brands, A and B. They have same battery life, 35, but wildly different performance. Which one of these feels more reliable? Brand B. This is why we need measures of variability. So today we are going to cover three measures of variability: variance, standard deviation, and range. The variance by definition is the average of the squares of the distance each value is from the mean. I do have two formulas for the variance. One if I am using population data, and one if I am using the sample data. Population data, the variance is called sigma square and it is calculated as such. The sum of square distances each observation is from the population mean over the total number of observations in my population. For the sample variance, it is calculated as the sum of the square distances each observation is from the sample mean divided over how many elements I do have in my sample minus 1. That minus 1 is just to make this S square the sample variance having good properties, statistical properties, as we will discuss later in our course. Now, if all of the observations in your dataset were equal, then there is no variability, meaning the variance is equal to 0. Standard deviation is calculated as the positive square root of the variance. So I will have two formula again, one for the population and one for the sample. Standard deviation is in the same units as the data, while variances are in squared units just because you are squaring here. Each data point is squared, which makes the unit squared. If you don't have access to the data values themselves and you need a rough estimate for the standard deviation, you can use the rule of thumb, which is saying the standard deviation is equal to the range over 4. But what is the range? The range is actually the difference between the maximum point and the minimum point in your data set. So if I don't know the data set, how can I know the range? Usually it's easy to know the range, or it's easy to guess the range than guessing the standard deviation. The range is our third measure of variability, and it depends on the extrema, minimum and maximum, and it is measured in the same units as the data, exactly like the standard deviation. Now, all of these three measures are for quantitative random variables. I cannot calculate it for any qualitative random variable. All of these measures has to be positive when you are calculating them. And all of these measures are sensitive to outliers, exactly like the mean is. Dot-tested electric razors from two brands, A and B. Data from the 6 electric razors from brand A are the whole population, while for brand B it was just a sample from a population. Let's calculate the mean first for brand A. The mean, this is a population, so the mean is the mu, sum of all my observation over how many observation do I have in my data. So it's the sum of these will give me 210 over 6 observations, gonna give me 35 months. And for the range, let me calculate the range first. Smallest observation is 10, while the highest one is 60. This will give me a range of 50 months. Regarding the variance by definition, variance of my population is sigma square. I'm gonna add all of the square distances each observation is from the mean. So to ease it on myself, I'm gonna just put the mean in that column and get the difference between each observation and its mean. It's gonna be here like minus 25, 25, and so on. Adding all of these will not help me because this is not the squared deviation or the squared distance. However, just to let you know, adding that column should give you always 0 unless you did do any rounding step before that step. It would be small but not 0, but still close to 0. Now we don't need to add that one, we need to add the square distance. So we are gonna create the square distance. So 25 times 25 or minus 25 times minus 25 is gonna give you 625, and so on for all of my remaining deviations or distances. Adding this now is my target. I need to put it here in my numerator. So 1750 over 6, it's 291.7 months. This is the variance, month square, because this is the variance. The standard deviation would be the square root of that number, which is 16.5 months. So I have that data set is having a mean of 35 months with a standard deviation of 16.5 months and a range of 50 months. Variance is 291.7 months square. Regarding our second data set, it is coming from a sample, and X bar rule is my target, that is the sample mean, and we are gonna just add all of my observations again, divide over how many value did I add, 6 again, adding these is 210, so it's gonna give me again 35 months. And the range, I'm gonna search here what is my maximum value and what is my smallest value. I have 45 and 25, so the range would be 20 months. And the variance, again, we're gonna follow the same steps, but using now the rule for the sample variance. Sample variance is the square distances, all of the square distances of your observations out from the mean, and divide over n minus 1 rather than dividing over n. So n minus 1 sample size 6 minus 1 would be 5, and we are gonna create again the same numerator here, putting here our X bar, get the difference, the distance would be 0, 10, minus 5, and so on. And if I add these, it's gonna give me 0, but I don't need that one. I need the square distance, which is that one. Adding all of these now is my target. This is my numerator. I'm gonna plug it here, and it's gonna give me 50. So the sample variance is 50 month square. I need something in the same units of my data. So S, the standard deviation, sample standard deviation is 7.1 months. Notice how the variability shifts between brands. Here much less variability than what we had here. We do have here price changes of oat milk across 15 stores over 6 months, and we would like to calculate the mean median mode. So let's crunch the numbers and see how central tendency and variability help us understand the market. Let's calculate the full set of measures: mean, median, mode, and mid-range. I put my data again in a table and I need to calculate the sample mean. I need to add all of my data values. So this is the sum. Divide over 15 because I have 15 values. It's gonna give me that value. And this value is rounded, by the way, to 3 decimal places. The median is by definition that value where 50% of my data above it and the other 50 below it. So I need to arrange my data first. So here is my arrangement. And now 50% above it and 50% below it, and I have 15 observation to know the 50% and above and below. Let's divide 15 over 2. It's gonna give me 7.5. This is not a position value. I need to round it up. So 7.5 would be 8. So the value exactly in position 8 is my median. So this is my median. The mode, to know it, I need to see what is the value that is having the highest frequency in my data. I can do it by scanning my values here. I do have here 359 appeared 3 times, 369 appeared 3 times, and so on. Or I can just put it in a table like that and just focus on those values that are having the highest observation. Here we have 4 of those values are having the same frequency, the highest same frequency, which is 333. So we are in a multimodal case and all of these values are modes. For the mid-range is the average of the maximum and the minimum value. The highest value or the minimum value is 3.49, while the maximum is that one. Get the average, it's add them, divide over 2, it's gonna give me 3.74. As for the range, variance, and standard deviation, well, let me also calculate these ones. The range is the maximum value minus the minimum value, which is 0.5. So the range of my data set is only 0.5. The sample variance is calculated using the sample variance formula where I am dividing over n minus 1. So n minus 1 would be 14. And that sum we need to do the same steps as we did before. So here is my X bar column. I'm gonna list in all of these cells my mean and get the deviation again. And now if I am adding this, it has to be 0 if I did not round up, but I did round here in one of my steps. So when I'm adding it, it's a little bit above 0, but still effectively 0 in terms of my data. But we don't need that. I mean, you don't need it in your calculations. This is just to shed some light about that fact. So what we need is to add the squared deviations. So let we get it first. Minus 0.273 square. It's gonna give me that value. And similarly for all the other values, I'm gonna square each value of these. Gonna give me these values. Add these up. It's gonna give me that value. This is actually what I need here in my sample variance, and I'm gonna divide over 15 minus 1, which is 14. So this is the variance. Now, as the standard deviation is the positive square root of that value, which is 0.162. Usually, if you're gonna round for the mean and the variance, you would round such that you will keep an additional decimal place more than what your data have. So here we have two decimal. Here I kept 3, and down there also I kept 3. It's a rule of thumb. So keep one additional digit in your rounded figures compared to the original data. The coefficient of variation, or CVAR for short, is defined as such. So standard deviation over mean times 100. And this CVAR is actually unitless scale. CVAR compares variability across different scales. Dot launched an Instagram campaign. Each post reached thousands, but did they engage her audience consistently? Let's calculate coefficient of variation for both metrics. For the CVAR, I'm gonna take the standard deviation, divide it over the mean, multiplied by 100, it's gonna give me 12% as a value for the CVAR, and this is unitless as we said before. For the engagement rate CVAR, it's gonna have a value of 21.4%. So the first variable, the post reach, is having low CVAR, which means that Dot's post consistently reached a wide audience, but engagement rate has much higher CVAR, meaning reaction was unpredictable. Some posts sparked while others faded. So while Dot's reach was steady, engagement was scattered. The CVAR helps us spot that inconsistency. Let's look at another example. Let's compare two features together, number of pages and number of interactive elements in online learning modules. These are measured on different metrics. So the first one, number of pages, is having a mean of 132 page with a variance of 23, while the second one is having a mean of 182 element with a variance 62. To compare the variability, we need to calculate the standard deviation of each one. So we are going to take the square root of that one and the square root of that one first, and then we are going to plug it into our formula for the CVAR. Doing that, we will get 3.6% as a CVAR for my first feature, the number of pages, while for the second one, we are gonna get 4.3%. And as you see here, I did take the square root of the variance to have here the S or the ST standard deviation. So this means that number of pages is having lower variability compared to the other one, which means it's more stable, while the other one is having some modules that are rich, some others are sparse, so the variability here is higher. Want to test your sleuthing skills? Interactive plots and mini quizzes are coming soon to StatSleuths site. So stay curious and keep sleuthing.